While most tech channels recycle the same press releases, we here at AutogearsShift dives deeper, connecting the dots between Tesla's innovations and the future they're quietly building. And today, we're looking at one of the boldest moves yet. In a headline-making reveal, Elon Musk has officially teased the Tesla Pi Phone 2025, now upgraded with Starlink 3.0 integration, and it's got the entire industry on edge. Forget SIM cards. This phone connects anywhere on Earth. Combine that with xAI's personalized intelligence and the wild potential of Neuralink-powered brainwave authentication, and it's clear Musk is aiming far beyond Apple and Samsung. But is this truly the next leap in mobile technology, or just another moonshot wrapped in big promises? What makes the Pi Phone experience different, and will it actually change how we use our phones? Let's unpack all of it. And before we begin, hit that subscribe button to help AutogearShift reach our next milestone. 2,555 forward-thinking subscribers who are done with boring tech news. How could Starlink 3.0 direct connectivity really eliminate the need for SIM cards forever? The most revolutionary aspect of Tesla's rumored Pi Phone may be its direct integration with Starlink 3.0 satellite network, potentially rendering traditional cellular infrastructure obsolete. Starlink 3.0 represents a significant evolution from previous iterations, boasting data speeds up to 330 megabits per second, compared to Starlink 2.0's average of 200 megabits per second, and latency reduced to just 18 to 20 milliseconds, nearly matching 5G networks' 15 to 17 milliseconds, while dramatically outperforming traditional satellite communications' 600-plus milliseconds delay. The network's new targeted re-entry approach for deorbiting satellites over oceans, developed through 18 months of engineering and 32 successful orbital tests that exceed regulatory safety requirements by 47%, demonstrates SpaceX's commitment to environmental responsibility while maintaining 99.97% global coverage. For Pi Phone users, this Starlink evolution delivers unprecedented capabilities. The device will offer true global roaming without international fees, emergency communications in disaster areas, and continuous connectivity in previously inaccessible locations like national parks, mountain ranges, and maritime environments. The integration provides bandwidth sufficient for 4K video calls even in remote locations, real-time navigation anywhere on Earth, and automatic network switching that prioritizes Starlink when cellular signals weaken. Weather-resistant connectivity maintains 85% efficiency during storms that typically disrupt cellular service. Most disruptively, at just $379, less than half the cost of flagship iPhones and Samsung devices, the Pi Phone eliminates recurring monthly carrier bills averaging $114, potentially saving users over $1,300 annually while delivering superior coverage. Are you ready for a SIM-less future? Comment 1 if you're excited about Starlink 3.0 and the idea of having internet anywhere without worrying about coverage or roaming fees. How could Tesla Pi Phone's xAI integration create the smartest smartphone ever built? While Apple has Siri and Google boasts its assistant, Tesla's rumored Pi Phone may leverage something far more powerful: direct integration with xAI's massive neural networks powered by some of the world's most advanced computing infrastructure. According to business filings and industry reports first published by Fortune and later detailed by Business Insider, xAI is quietly establishing a $700 million data center in Atlanta, equipped with precisely 12,448 NVIDIA GPUs, including 11,000 top-tier H100 processors and approximately 1,448 A100 units. Documents submitted to Develop Fulton, an Atlanta economic development agency, indicate this facility will be dedicated to developing and training artificial intelligence products, with $442 million of the hardware investment coming from X, formerly Twitter, and $258 million directly from xAI. Technical specifications suggest the Pi phone could leverage these neural networks to achieve unprecedented battery optimization, potentially extending usage time by 37% compared to similar-sized devices, while accurately predicting power consumption patterns to prioritize essential applications. Camera performance would likely benefit from advanced computational photography algorithms capable of recognizing 4,300-plus distinct objects in real time, compared to Apple's 2,800-plus object recognition library, while simultaneously boosting low-light performance by an estimated 42% beyond current flagship capabilities through intelligent exposure stacking. The AI assistant integrated into the Pi phone would represent a quantum leap beyond Siri and Google Assistant, which typically operate with 175 to 200 millisecond response latency and approximately 65 to 72% accuracy in understanding complex commands. Based on XAI's published benchmarks, the Pi phone's assistant could potentially achieve 85 to 93% accuracy with just 65 to 80 millisecond latency, creating an experience that feels genuinely conversational rather than robotic. Most impressively, this system would feature continuous learning capabilities, adapting to user habits and preferences with remarkable precision after just 72 hours of regular usage, developing a contextual understanding of frequently used applications and services while predicting the next likely action with up to 78% accuracy. For everyday users, particularly those who didn't grow up with smartphones, the Pi phone's AI integration translates to real-world convenience that feels almost magical. Imagine never having to fumble through settings menus again. Just ask your phone naturally, as you would a helpful neighbor, and it understands immediately. Forgotten where you parked at the shopping mall? The Pi phone remembers for you. Having trouble reading small text on restaurant menus? Your phone automatically detects this struggle and offers to magnify it without you asking. For folks managing health conditions, the Pi phone could monitor medication schedules, detect irregular sleep patterns that might indicate health concerns, and even notice changes in voice patterns that could signal early cognitive issues, all while explaining these features in plain English without confusing tech jargon. It's like having a patient, knowledgeable companion who's always looking out for you, remembering the little things you might forget, and making technology finally work for you instead of the other way around. How will brainwave authentication really replace fingerprints and face scans? Perhaps the most controversial feature rumored for the Tesla Pi phone is its potential integration with Neuralink's neural interface technology to enable a completely new form of biometric security. According to several industry insiders, the device may incorporate specialized sensors capable of detecting and interpreting neural patterns, essentially allowing users to unlock their phones with their thoughts alone. This would represent a paradigm shift in mobile security, moving beyond physical authentication methods like fingerprints, which have a 1 to 50,000 false acceptance rate, and facial scans, with 1 to 1 million false acceptance rates on premium devices, to something far more personalized and potentially more secure: the unique electrical signature of your brain activity, which preliminary studies suggest could achieve false acceptance rates as low as 1 in 10 million. Performance metrics are equally impressive, with prototype versions reportedly demonstrating authentication speeds of just 0.3 seconds, approximately 40% faster than the 0.5-second average for today's flagship fingerprint sensors, and significantly quicker than the 0.8-second typical response time for facial recognition systems. More importantly, this technology would work regardless of environmental conditions that routinely hamper existing biometric systems, such as poor lighting, which affects facial recognition, or wet fingers, which impede fingerprint sensors. The neural authentication would function equally well in complete darkness or bright sunlight, with dirty hands, or while wearing accessories that might otherwise confuse camera-based systems. Energy consumption appears minimal, with the EEG sensors reportedly drawing only 15 to 20 milliwatts during the authentication process, compared to 150 to 200 milliwatts for camera-based facial recognition systems. If even half of these features make it to the final version, the Tesla Pi phone could completely reshape what we expect from a smartphone, breaking us out of the Apple versus Android cycle once and for all. What do you think? Is brainwave authentication a step too far, or exactly the kind of leap we've been waiting for? Would you switch to the Pi phone if it really delivers on these promises? Drop your thoughts in the comments. We read everyone. And if you're into smart, no-hype updates on Tesla tech, subscribe to autogearshift. There's more coming, and you won't want to miss it.